Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. In this video, we'll be tackling problem number 14, which is very similar to our problem from our last video. They both deal with different types of solutions to systems of equations. This problem says, in the system of equations below, A and C are constants. It gives us two equations, 1/2 x plus 1/3 y equals 1/6, and ax plus y equals c. If the system of equations has an infinite number of solutions x, y, what is the value of A? -1/2, 0, 1/2, or 3/2. So we'll start by just reviewing what the different kinds of solutions to systems of linear equations can be. So let's say we have a graph. And on that graph, we have two lines corresponding to two linear equations. They can either intersect at a single point, in which case there's one solution to the system of equations. They can be parallel, like they were in the last video, in which case the lines never intersect and there are no solutions to the systems of equations. Or they could be the exact same line, in which case every single point on that line is a solution to the systems of equations, or in other words, there's infinitely many solutions. This video is asking for the situation in which there are infinitely many solutions. So we have to find the values of A and C such that these two equations are equal to each other. In other words, there are infinitely many solutions. So we'll write these equations down. We have 1/2 x plus 1/3 y equals 1/6, and ax plus y equals c. Now this problem is actually a little simpler than the last problem because we're looking for the exact same equations. We don't have to actually necessarily rearrange them into slope-intercept form to isolate the slope and isolate the intercept. We just have to find the values of A and C that would make these two equations identical. Now, A and C are constants that are unknown. They could theoretically be any numbers that we need them to be. However, if we look at these y terms here, we can see that they are not yet equal to each other because in this first equation, the coefficient for y is 1/3, and in this bottom equation, the coefficient for y is 1. So the first thing that we definitely have to do is make those equal to each other. So the way that we're going to do that is we're going to take this bottom equation and we're going to multiply it by 1/3 on both sides. When we multiply it by 1/3 on both sides, we're not changing the relationship, we're not changing the equation, we're just writing it in a different form. So we'd get 1/3 ax plus 1/3 y equals 1/3 c. And now the coefficients of our y terms are equivalent, which means now all we have to do is find the values of A and C that make the coefficients of our x terms and constant terms equivalent, and then we have found the values of A and C that make these two equations the exact same equations. However, for us, the problem is only asking for what the value of A is. So even though if we wanted to find what the two values were to make these equations the same, we would have to solve for C. For the sake of this problem, we only have to solve for A. We only have to solve for what is the value of A that would make this coefficient for x the same as this coefficient for x. In other words, what is the value of A such that 1/3 A equals 1/2? And that's very easy to solve for. We can just multiply by 3 on both sides, and we get A equals 3/2, or in other words, option number D. So option number D is our final answer, and once again, this is a problem that might seem difficult at first, but it is really very simple. We're trying to find infinitely many solutions, which means we're trying to find the values that make these lines the same. As long as we can set our y terms equal to each other, we can then just find the value of A, which will make this x coefficient equal to this x coefficient, solve for that, and get D. Very simple, very straightforward. I hope you enjoyed the video. I look forward to seeing you in the next one.